We are living on Earth, which is revolving around the axis, as well as revolving around the Sun. But the Sun revolves around the center of the Milky Way galaxy, so it is important to know about the galaxy. It is important to know fundamentally the galaxy. Actually, it will help to understand about the Milky Way galaxy. My next mission is Milky Way galaxy. Why should know about the galaxy? Here are some reasons why it's important to know about galaxies. Understanding the universe. By studying galaxies, scientists can learn how matter is organized in the universe and how that organization has changed over time. Discovering planets. Studying galaxies helps astronomers deduce if planets exist around other stars. Understanding the structure of the universe. The large-scale structure of the cosmos, which is made up of galaxies distributed in clusters, filaments and walls, can help us understand how the universe has evolved. Learning about the Milky Way. Studying our own galaxy, the Milky Way, helps us understand how it formed and what continues to shape it. Types of galaxies. Spiral galaxies, elliptical galaxies, lenticular galaxies, irregular galaxies, active galaxies, Seyfert galaxies, quasar, blazars, spiral galaxies. A spiral galaxy typically has a rotating disk with spiral arms that curve out from a dense central region. The Milky Way is a spiral galaxy. Spiral galaxies have a complex structure. A dense central bulge lies at the center of a rotating disk, which features a spiral structure that originates at the bulge. Spiral galaxies are surrounded by sparsely populated halos, roughly spherical regions above and below the plane of the disks. A central concentration of stars known as the bulge. The Milky Way is a barred spiral. Types of spiral galaxies. Spiral galaxies are classified by a number of factors, including the size of their central bulge, the tightness of their spiral, and the lumpiness of their arms. There are three main types of spiral galaxies. Spiral galaxies. These galaxies have a large central bulge and smooth, broad spiral arms. Spiral galaxies. These galaxies have a medium-sized nucleus with spiraling arms around the nebula. Spiral galaxies. These galaxies have a small bulge in the center and narrow, well-defined arms. There are also three types of barred spiral galaxies. Barred spiral galaxy type A S-bar. These galaxies have tightly bound arms. Barred spiral galaxy type B SBB. These galaxies have both tightly and loosely bound arms. Barred spiral galaxy type C SBC. These galaxies have loosely bound arms. Elliptical galaxies. An elliptical galaxy is a type of galaxy with an approximately ellipsoidal shape and a smooth, nearly featureless image. Elliptical galaxies range in size from dwarf ellipticals with tens of millions of stars to supergiants of over 100 trillion stars that dominate their galaxy clusters. Elliptical galaxies vary greatly in both size and mass, with diameters ranging from 3,000 light-years to more than 700,000 light-years and masses from 105 to nearly 1013 solar masses. This range is much broader for this galaxy type than for any other. Hercules A, supergiant elliptical galaxy. Math A1, the closest giant elliptical galaxy. There are two types of elliptical galaxies, giant ellipticals and normal and dwarf ellipticals. Giant ellipticals have a slightly boxy shape, while normal and dwarf ellipticals have a disky shape. Lenticular galaxies. Lenticular galaxies S0 galaxies are a type of galaxy that exhibit characteristics of both spiral and elliptical galaxies. Basically, they are combinations of spiral and elliptical galaxies. Scientists have a few theories about how lenticular galaxies evolve. One idea suggests these galaxies are older spirals whose arms have faded. Another proposes that lenticulars formed from mergers of spiral galaxies. But like ellipticals, lenticular galaxies have older stellar populations and little ongoing star formation. Few lenticular galaxies are as below. NGC 2787. Sombrero Galaxy. NGC 1316. Irregular galaxies. Irregular galaxies have unusual shapes. Irregular galaxies born from galaxy interactions or collisions typically host a mix of older and younger stars, depending on the characteristics and composition of the original galaxies. Irregular galaxies may also hold significant amounts of gas and dust, essential ingredients for making new stars. Some irregular galaxies are as below. Cartwheel Galaxy, IC 10, NGC 7292. Active galaxies. Active galaxies, also known as agons, are galaxies that emit more energy than normal galaxies and are powered by a supermassive black hole at their center. Energy. Active galaxies emit energy in many wavelengths, including radio waves, gamma rays, and high-energy particles. Black hole. The black hole at the center of an active galaxy can be millions or billions of times the mass of the Sun. Accretion. The black hole accretes matter from the galaxy's central region, which heats up and spirals into a disk. Jets. The nucleus of an active galaxy can eject jets of charged particles that move at nearly the speed of light. Classes. Active galaxies are divided into classes such as quasars, radio galaxies, and Seyfert galaxies. Variability. Active galaxies are highly variable and can exhibit rapid changes on short time scales. The hot accretion disks of active galaxies can be detected at great distances, making them useful for studying the farthest reaches of the universe. Seyfert galaxies. In 1943, the American astronomer Carl Seyfert (1911–1960) drew attention to a handful of spiral galaxies that had unusually bright point-like nuclei. It has been found that compared to normal galaxies, Seyfert galaxies show an excess of radiation in the far infrared and at other wavelengths. Example of Seyfert galaxies are as below. NGC 4051, NGC 1097, NGC 1672. Circinus Galaxy. Quasar. Quasars are the blazing centers of active galaxies and are powered by a supermassive black hole feeding on humongous quantities of gas. An active galaxy is one in which the central supermassive black hole is consuming large amounts of matter. Quasars are the remarkably bright cause of active galaxies in the distant universe. They are an extreme form of what astronomers call active galactic nuclei, or AGN for short. Here are some examples of quasar galaxies. J529 to 4351. This quasar is the most luminous object in the known universe. It's so far away that its light took over 12 billion years to reach Earth. 3C273. This is the closest and brightest quasar, and can be seen by amateur astronomers with an 8-inch telescope. It's located in the Virgo constellation. NGC 6240. This is a nearby system of merging galaxies that may have 2 or 3 supermassive black holes. M87. This galaxy has a supermassive black hole that weighs 6,500,000,000 times the mass of the Sun. Blazars. What they are. Blazars are a type of active galactic nucleosciga that are powered by a supermassive black hole. They are known for their relativistic jets, variable emission, and flat radio spectra. How they appear. Blazars appear star-like, and are visible across the electromagnetic spectrum. They appear especially bright when one of their jets is aimed in the direction of Earth. How they are classified. Blazars can be classified into 3 categories, based on their synchrotron peak. High synchrotron peaked HSB, NUS 1015 Hz. Intermediate synchrotron peaked ISB 1014 NUS 1015 Hz. Low synchrotron peaked ELSP NUS 1014 Hz. How they are studied. NASA's Fermi Gamma Ray Space Telescope is the primary tool used to study blazars. When a flare erupts, the SWIFT satellite is quickly pointed toward the source to capture ultraviolet and X-ray readings. How they were discovered. Blazars were only recognized as a distinct class of object in the 1970s. Structure. Core often contains a supermassive black hole. Disk contains stars, gas, and dust, with spiral arms in spiral galaxies. Halo, a spherical region surrounding the galaxy, containing older stars and globular clusters. Other details of the galaxies that will define galaxy are as below. Galactic dynamics. Galaxies are not static, they undergo complex interactions. Galaxy formation formed from the gravitational collapse of gas clouds in the early universe, leading to star formation. Merger and interaction. Galaxies can merge, leading to the formation of larger galaxies and triggering bursts of star formation. Rotation curves the motion of stars and gas in galaxies, helps measure their mass, indicating the presence of dark matter. Dark matter and dark energy. Dark matter. Most of the mass in galaxies is not visible. It's composed of dark matter which affects galaxy formation and rotation. Dark energy, a mysterious force driving the accelerated expansion of the universe, influencing the large-scale structure of galaxies. Galactic evolution. Galaxies evolve over billions of years. Star formation rates vary with time. Galaxies can experience bursts of star formation or become quiescent. Metallicity, the abundance of elements heavier than hydrogen and helium, increases over time as stars evolve and explode as supernovae, enriching the interstellar medium. Galaxy clusters and superclusters. Clusters. Galaxies group together in clusters, held by gravity. Clusters can contain from a few to thousands of galaxies. Superclusters. These are vast groups of clusters, and are among the largest known structures in the universe. Observational techniques. Astronomers study galaxies using various wavelengths. Optical telescopes like Hubble capture visible light, revealing structure and star formation. Radio observations help study gas and cosmic microwave background radiation. Infrared, useful for observing dust-enshrouded regions and cooler stars. Current research and discoveries. Galaxy formation theories. Research continues on how galaxies form and evolve, including simulations of early universe conditions. Exoplanet studies. Some galaxies host potentially habitable planets, with ongoing efforts to discover more about these worlds. Cultural and historical significance. Galaxies have been subjects of human curiosity for centuries, influencing mythology, navigation, and scientific inquiry. Modern understanding has transformed our perception of the universe, highlighting the vastness and complexity of cosmic structures. Conclusion. Galaxies are fundamental building blocks of the universe, offering insights into cosmic evolution, the nature of dark matter and dark energy, and the potential for life beyond Earth. Their study remains a dynamic and essential field in auspicious. Thanks for watching this video. If the given information is helpful, then give suggestion in the comment box.